Hi, this is Steve with DECWARE. Today I want to talk briefly about amplifier input sensitivity and how it determines where you set the volume control. A DAC or CD player will typically have an industry standard signal level of 2 volts, yet the majority of amplifiers will have an input sensitivity that is closer to 1 volt, which simply means that it takes 1 volt to bring the amplifier to full power. Volume control settings on amplifiers or preamps are entirely relative and not standardized across devices, which can lead to confusion when switching gear. What reads as 50% on one amp might equate to full blast on another due to differences in input sensitivity. If you're accustomed to an amp with high input sensitivity, upgrading to one with lower sensitivity might make it seem underpowered because you'll need to crank the volume knob higher to achieve the same loudness. This isn't a flaw. It's simply a design choice that assumes a stronger upstream signal, and as long as the amp reaches its full power output with the volume at or before full, there's no issue. So you may be wondering what would make someone choose to design an amplifier with a high or low input sensitivity. I can only speak for myself, but since there is nearly always going to be 2 volts, the only reason to have an input sensitivity where an amplifier requires less than that, such as 1 volt or even a half a volt, completely escapes me. If you wanted to listen to sources with lower output, perhaps a vinyl rig with a low output cartridge, you would just add a preamp to introduce some gain into the equation. Having amplifiers with a high input sensitivity, in my opinion, contributes to the thin, aggressive signatures of so many high-end amplifiers today. This signature is somewhat balanced by the lower efficiency speakers, with cheap to modest crossovers acting together as a filter to keep you from dwelling on it. Then a high-efficiency speaker, perhaps even crossoverless, comes into the picture and the filter is now gone. Most of the time we shoot the messenger, instead of admit our gear isn't what we thought. Anyway, the reasons for using a lower input sensitivity that more closely matches the output of a 2-volt source are as follows. 1. Clipping. 2. Pressure. 3. Gain structure. 4. Sound quality. Let's talk about clipping. Since our first amplifier, and still our most popular, is only 2 watts in a world dominated by low sensitivity loudspeakers, it's a given that many customers will turn up the volume to see how loud it will go as they discover what speakers the amp will drive loud enough to be enjoyable. If when the amplifier runs out of power, the clipping sounds like the speakers are breaking, it's going to horrify the customer. Since the standard source voltage is 2 volts, we set the amplifier's input sensitivity there. This way you have to turn the volume all the way up before there is any possibility of clipping, and if it happens, it is slight. Over the years, we have refined the setting to between 1.5 and 2 volts, depending on the amplifier. Pressure. Pressure in the interconnect is voltage. If you can increase the signal voltage, the interconnect cable it travels through has less effect on the sound quality. That is exactly the same sonic result that would have occurred had you purchased a more expensive interconnect. Gain. Gain structures, in my experience, should exploit this by never turning down the original source voltage until the very last possible point, which would be in the amplifier. That means you have to have an input gain control or volume pot on the amplifier itself. With it, this happens automatically, and the gain is structured optimally for any volume. You can increase the effect by introducing a preamp, which allows you to turn the 2 volts coming from the source up to 6 or 8 volts, and then squeezing it back down at the amplifier's input gain control. The sonic result of this approach would be sound density. The music has dynamics, weight, hit, surprise, and wonderful liquidity, which is quite the opposite of today's. Dry, clinical, somewhat lean sound that results from the industry's upside-down gain structures. Anytime we have a preamp with gain, we use the gain. We turn the signal up, and we turn the input gain control on the amplifier down to increase the pressure in the cable. Sound quality. volume controls sound better in the higher ranges. The reason for this is that the carbon trace inside the control goes from a thin strand to a thick trace, so as you turn up the control, the contact area is increasing and any sonic intrusion into the signal path is being reduced. If your system gets loud in the first quarter turn of the volume control, your gain structure is what I would consider upside down. Having a lower input sensitivity forces any volume controls in the signal path to be turned up higher where they sound better. Thank you for listening, and have a great day.